Good afternoon, everybody. My name is Pieter Poppe, and I will give you a presentation concerning the VIPA study on fire safety in homes for the elderly. I don't know if any of you saw me last year, but I did also a presentation on the VIPA study. And during that presentation, the focus was more on the large-scale tests we have done. During this presentation, I will go further in detail on the results of these large-scale tests and how they were used to apply fire safety measures. First of all, during the presentation, if you have any question, remark, please don't hesitate to raise your hand. If possible, raise your voice also, so everybody can hear, and we can discuss it during the presentation. First of all, I will refresh the scope of the VIPA study. Then after that, I will give a brief description of the large-scale test we have done. But basically, what we will discuss today in detail will be the desired safety level in homes for the elderly in Flanders, especially in Flanders. Also, we will discuss fire safety measures to obtain that determined fire safety level. And at the end, of course, conclusions. First of all, the VIPA study. The VIPA study was a study where they wanted to investigate alternative fire safety measures and new care concepts. I will explain a little bit later on what it's all about, but you have to keep in mind that VIPA is Flemish government. You can relate to Flemish government, and Flemish legislation for homes for the elderly is basically a prescriptive legislation with focus on passive fire protection. This is very important, so passive fire protection, compartmentation, and so on. If you deviate from the legislation, these things will be handled by the Technical Commission, Fire Safety. The new care concept, as I was talking about, are, as you see, the trends in homes for the elderly. And you see in this figure here that the common area more and more is located in the evacuation route. As you can see, these are the rooms, evacuation, so common areas are more and more located there. On such, it's no problem, but they do kitchen activities, for instance, in these common areas. So it is a fire hazard, and at that moment it's no longer okay. So the activities, the fire hazards that they have there have, of course, an influence on the fire safety, but it's not provided in the Flemish legislation. So you have to apply alternative fire safety measures in order to obtain the same safety level. I think that's the basic of every deviation from legislation. What are these alternative fire safety measures? You have a chef system, an automatic suppression system. In this case, we used a sprinkler system. But what will be the influence of these alternative fire safety measures on the safety level? So they decided to perform a study, and the purpose of the study was to provide an assessment framework that the Commission, the Technical Commission, can use to deal with their deviations. The VIPA study was done in 3 phases. The first phase was studying legislation in other countries, if there's something similar. We also did a study of what kind of alternative fire safety measures are available. And in this case, it was active fire protection. And then, of course, before doing a test, you have to determine the test configuration and the fire scenarios. That was phase 1. Phase 2 were the large-scale tests. As you can see presentation last year. Well, I don't think the presentation is on slide, but they told me you can find it on YouTube. So click on it. The last phase, we did some additional CFD simulations, and the reason why, I think it's obvious. You have a limited amount of large-scale tests, But if you want to see influence of other parameters, for instance, doors that are open or ventilation system that are adapted and so on, you use CFD simulations. After that, there was the determination of the safety level. I have to say, in case of the elderly, it's very important. I will mention it later on, but the safety level in case of the elderly. After we have determined the safety level, we had measures to obtain that safety level. Just a refresher, this was the first test we did. As you can see here, this is the common area. These are the evacuation routes. So the purpose was, and this is our fire source, the purpose was to look at smoke propagation if you have a fire in the common area and smoke propagation going in the evacuation routes. That was the purpose of these tests. You see here a room and another room, and they are connected with the evacuation route by means of either a fire-resistant door or a smoke control door. This is just to give you an idea about the fire source. We will see in the conclusions, but after 2 minutes, 3 minutes, and this is already after 4 minutes. So it's a common couch, but you see that it can develop very rapidly. During the second test, we applied fire-resistant doors, separating the common area from the evacuation route. We used a double hinge door and a pivot door. So here you see that there are the openings, and that was the difference. We thought that would give a difference, but apparently it didn't. In the third test, we used a chef system with air supply here and air smoke extraction here. You already see there's a huge amount of extraction and supply volume, but the reason why is there is no standard defining these kinds of chef systems. So we used a rather severe system. And the fourth test, we used a sprinkler system. As you can see, only located here, because the fire source, in this case, we knew where the fire source was.
Where's the ventilation of the room? Is there?
No, it's closed.
It's closed.
Yeah. Sorry to yeah, that's very important. It's closed. So during the test, these doors are closed and these doors are also closed. That's a very good remark. You will see later on.
Is there enough oxygen?
No. No. I think you better check YouTube. No, we have the complete study. Also, you can download it from internet. I think it's at the end of the presentation. Yeah, and the last test we did was a combination of sprinkler and a chef system. Because, as you know, we found out that if a smoke extraction system helps to evacuate the smoke but doesn't control the fire, sprinkler controls the fire but doesn't put away the smoke, logically, if you do both, it will be okay. Conclusions will be told later. First conclusion of the large-scale test is that your fire compartment is filled very rapidly with smoke. If you can remember the picture of the couch, after 3 minutes it was beginning to burn good. But after 3 minutes, it's filling very rapidly. At 4 minutes, you don't see anything. You have to keep in mind this was a volume of around 300 cube. So even with a small fire, the fire compartment fills up very rapidly. This is a very important conclusion. Second, I think more important conclusion is pressure buildup. Because in your fire compartment, and because it's confined, you have pressure buildup. If you have pressure buildup, then your smoke will want to go outside through openings. And this was the second test. And you see here the fire-resistant door. And after a couple of minutes, this is the evacuation route. So the evacuation route that was separated from the fire room by a fire-resistant door doesn't help a lot in this case. I have to say in this case. Maybe a reason why it's only after 2 or 3 minutes that it's becoming to more and more unclear is because your door isn't up to the ceiling, of course. Smoke has to descend first and then can be pushed to. So should the door be till the ceiling, you will have quicker smoke propagation. Another very important conclusion, fire-resistant doors are no smoke control doors. Seems obvious, but in Belgium, we don't know the concept of smoke-free doors, of smoke control doors, until now. A last conclusion of the test, this gives you some nice colors, and it says, it's basically saying that if it's red, you have bad visibility, if it's blue, you have good visibility. Meaning that if you have the fire-resistant doors, this is the common area, this is the evacuation route, it's red, so a lot of smoke. If you have a chef system, still a lot of smoke. If you have a sprinkler system, still a lot of smoke. Because the sprinkler system is only activated at a certain temperature, so there is already a lot of smoke. Best results here if you combine those two. But again, you have a very high extraction rate. It's not realistic for these kinds of applications. You have to keep in mind it's for the homes of the elderly. I don't think they will use 40,000 cube per hour as a smoke extraction. It's not realistic, but it gives you an idea of where to go to. These were the tests. I've gone rather quickly through them, but they are important for the next slides. So, as you know, prescriptive legislation has a kind of safety level already incorporated. But you don't know what you have to measure or what values you have to obtain in order to declare that it's safe. So what we did is, first of all, we want to have a safety level, meaning you want a safe evacuation to a safe location. It's two different things. For instance, safe evacuation can be different for an elderly than for an adult. A healthy adult can be different. So when is it considered a safe evacuation? I think it's obvious that every person, staff and occupants, are located to a safe location. There's not only the elderly, but also the staff. In general, we say what is a safe evacuation if you're not exposed to the consequences of fire, so high temperatures, visibility, toxicity, and so on. But in case of the elderly, it's mainly smoke that is a problem. So in this study, to determine the safety level, we used smoke as a criterion. And if you have already fixed that, so you know we are looking at smoke, you have two kinds of smoke propagation. You can have a two-zone model, that's what you see here, so clear distinction between smoke and the air, and then you can find quantitative values in literature or even in legislation that I have examined in other countries, saying that you need a smoke-free height of a minimum height, that your temperature of smoke layer may not exceed a certain temperature, or the flux. Well, these two are mainly connected by them. That is in case of a two-zone model. In case of a room completely filled with smoke, you have different values to look at. You have your temperature of your smoke, you have visibility and toxicity. But these values apply for all types of buildings and for healthy, self-reliant, and adult persons. So these things found in literature are for that specific kind of persons. So if we look at now we have distinction between what to look for smoke. Evacuation under the smoke layer, if the height of your ceiling is 2.5, and you say that your minimum height of your smoke layer is 2.5, I don't think this will be a criterion. So we will look at evacuation through a smoke layer. First of all, as I said, temperature. These volumes, I have 60 to 80 degrees, because in some countries it depends. In one country it's 60, in another one is 80, but temperature on itself is not sufficient. You have to keep in mind that exposure time and humidity are also important. It's not only temperature. And you know that in case of the elderly and children, they are more vulnerable by high temperatures. And temperature of a smoke layer doesn't say anything on toxicity. Oh, was too quick. Visibility, there are also some values, but in case of healthy adults, the time exposure is also less, because they can go much quicker through the smoke. And also no information on toxicity. And now we come to toxicity. So you know that if you want to, in literature they say, if you want to have a successful evacuation, you must be below certain values, FED, FEC. So it depends on the exposure time or the exposure concentration of your smoke. But in any way, if you inhale smoke, it's bad for you. So that's a fact. All these values, again, are applicable for healthy, self-reliant adult persons. The influence in case of elderly are much, much higher. And if you see that in case of accidents, that elderly die not at the moment of the accident, but a couple of days later on, then you know that it's very difficult to say what value you can apply. So the first conclusion, in order to determine the fire safety level, is you cannot evacuate through a smoke layer. In case of the elderly, again, we are talking about elderly. So you cannot, it's only possible if the evacuation route is kept smoke-free as good as possible, because smoke-free, that doesn't exist. We have also conclusion on smoke propagation in the fire compartment. With the large-scale test, we have seen that it filled very rapidly with smoke. We have seen that even if you have a sprinkler system, the smoke remains in the room. And then we did some additional CFD simulations in order to see if an existing ventilation system in combination with a sprinkler can be used. We have seen that an extraction system, very high extraction rates, is okay, but technically it's only possible to do more or less twice the flow of a ventilation with the same system. And even with that, the room was not kept smoke-free. So, conclusion 2, an evacuation is not possible through the fire compartment because you cannot keep the fire compartment smoke-free. It's related to the first conclusion, but this is the fire compartment. Third conclusion, well, later on. And third conclusion is, we have seen that smoke propagation is also very tricky when you look at adjacent compartments. Because of your pressure buildup in the fire room, you can have smoke propagation to other rooms. Fire-resistant doors are no smoke-free doors, but it doesn't only fire-resistant doors. If any kind of passive instrument of material that's there, is fire-resistant, it's not to keep the smoke, it's to keep the fire in the room.
With the new system with the S classifications, smoke lead classifications, then you get real smoke.
Yeah, well, yeah, but that's for doors only. Suppose you have ventilation system, then it doesn't say anything on that. But we will see that later on. Smoke control doors have an S classification, and they are designed to keep the smoke as good as possible, because it's not smoke free. There's still coming some smoke through the doors, but limited. What we also saw, that there was no smoke propagation to the room if it's separated by 2 doors. Meaning that you have your common area. There was a second test. Door is closed. You have evacuation route, where we have seen a lot of smoke. And then you have your room. And in the room, there was no smoke. So if you're separated from your common or fire room by 2 doors that are closed, there is no smoke in that room. I've put there fire resistant between brackets, because in the beginning of a fire resistant door or door is the same. It's only at the later stage that the door becomes fire resistant. But if you have 2 successive doors, they are breaking the pressure buildup enough to prevent smoke in your room. So, if we want to successfully evacuate elderly through an adjacent compartment from the fire compartment, we have to take adequate fire safety measures. I will tell you more about these things, just to eliminate the pressure buildup and to prevent the smoke propagation. I think everybody knows the difference between ASET and RSET. Nevertheless, I will shortly mention it. So the ASET, in this case, depends on the exposure to smoke in the evacuation route or in the room. I will tell you more about evacuation strategies. And also the time is determined on the basis of the large-scale test and CFD. The required safe egress time depends on the location of the room, the fire compartment, and the evacuation route. Evacuation route through a fire compartment is not possible, that's a conclusion. And if you have non-self-reliant persons, you need staff to help them to evacuate. That's also very important. So, as I said, now bigger than RSET, at this moment we don't know. So we performed fire scenarios. So far, any questions on? I know from my previous presentation that the questions will come later on. So, yeah.
The scenarios you showed,
yeah.
Is that including the smoke detection already or not? You talk about. Okay.
You're too quick. That's good. That's good. So we performed fire scenarios, and fire scenarios we did it in function of the configuration of the room. The room opens to the evacuation route, so we tried to have one clear picture of all different kind of situations. We have, like you see here, in this case, it comes to the evacuation room, or it can go directly to the common area, or in this case, the fire compartment. There's 2 situations. You can also have a different evacuation strategy, or you can evacuate from the room, or you can stay in your room. I had to be very creative with that symbol because it was not, you know what it means if you see it. So these are 2 basically different evacuation strategies. So we did these fire scenarios with all these different things. What we also did is we take into account the results, of course, of the large-scale tests, meaning your fire compartments filled very rapidly with smoke. You cannot keep the fire department smoke-free, and if you have pressure buildup, that means that you have smoke propagation. That's basically the tests. But on the other hand, we have to take into account that there's a desired safety level for the elderly, meaning you cannot evacuate through the fire room. You must keep the evacuation route smoke-free. And you have to make sure that if you go to another compartment that's located next to the fire room, is also kept smoke-free, meaning that you have no smoke propagation. Of course, if you do fire scenarios, you have assumptions. And it was during these assumptions that I had a lot of response. First of all, the fire starts in a common area. Not in the room, in the common area. This is important. Only an evacuation from the room is considered, not from the fire compartment. Meaning that if there's a fire, there's assumed that everybody has left the compartment. It's also important. Non-self-reliant persons stay in their room. That's an assumption. Evacuation starts at the earliest 5 minutes after the start of the fire. 5 minutes, is that okay or not? We assumed that because we said start of the fire, meaning that you have to detect it after 1 minute, you have to give signal to this. We said 5 minutes. It's an assumption. Time required, and this is very important, for one staff member to assist one non-self-reliant person to safety, minimum 2 minutes. And at that moment I had a lot of reaction that 2 minutes is too low. Meaning that your staff, suppose you have one person, comes in, takes the person, takes them to another, and then, so it takes 2 minutes, and 2 minutes was very, very small. It was discussion. But we saw that it doesn't matter if you do it in 20 seconds or you do it in 2 minutes, it doesn't matter. The smoke fills the room so rapidly that these times are not so relevant. We took 2 minutes, it's very fast. You can argue it has to be 3 minutes, but it made no difference. Activation time of fire detection, 1 minute. I think that's normal. During the test, we had an activation after 1 minute. It's also because your ceiling height is 2.5, so it all depends, 1 minute. Activation sprinkler system between, it's more or less 2 and 3 minutes. I will tell you later on what kind of sprinkler system is. But during these simulations also, we used alpha T square medium. It's more or less based on the couch. And depending on the position of your fire source, if it's in the middle or in the corner, it's more or less that. What kind of fire safety measures are they? We have trained staff. I've put between brackets what's already foreseen in the Flemish legislation. So trained staff is foreseen. And that the second one is coming with the detection system. It's already foreseen. So staff and detection system is already foreseen. It's obliged. You have to put it there. What it's not foreseen, and that was what we had seen during the test, you have to have measures to eliminate the pressure buildup, because it's the main cause of smoke propagation. There are two things we proposed. You have residential sprinklers with an activation temperature of 86 and an RTI, a response time index of 35. This is very low, meaning that these residential sprinklers will activate very quickly. Or what you can do is you put an opening in the wall. As you know, if you have pressure buildup, you have an opening, the pressure will go out of the opening. So this was based on additional CFD simulations to have a value of, in this case, 0.25 square meter, and you have to apply it in the upper region of your room. This is all to eliminate your pressure buildup in the fire compartment, of course. What are other available fire safety measures that for the door requirements? You have, in this case, fire resistance classification. In Belgium, it's EI1, but it was, of course, already foreseen. But new is smoke control. And there you see the SA or the S200 classification. The S200 is the previous SM classification. But they changed it now. So the S200 is the SM from previous. And another very important, it has to be self-closing in case of fire. Because in Flanders we had the accident where the door was left open. It was a fire in a room. The corridor was completely filled with smoke. So I think 10, 11 people died. On the basis of that, they put in the legislation, it has to self-close in case of fire. I don't know in the Netherlands it's the same, but this is specifically for the elderly. And something new is an additional exit in the room. I will tell you later on why this is important. But the application of each fire safety measure, so all the safety measures I've mentioned, will depend on the configuration of the room and the evacuation strategy. And then we come to this table. We have two different configurations. In this case, we have the room that comes out to the evacuation route. So, evacuation route is separated from the fire compartment by means of a door. These are the measures that I was talking about, and for staff and fire detection system, there's an X, meaning you need it, but it's already foreseen, so therefore the X's are there. You have measures to eliminate pressure buildup in the fire compartment because of smoke propagation otherwise. The common area door is the number 2. You have requirements for that. And you have requirements for the room door. We have 2 evacuation strategies. We have evacuation from the room and defend in place. We will see one by one what are the measures you have to apply in case of your evacuation strategy. So let's take first evacuation from the room. Measures to eliminate pressure buildup. If you want to evacuate from the room, that means that you will use evacuation route. We have seen during the tests that if you have pressure buildup here, you have a problem in your evacuation route. So a requirement is you need something to eliminate the pressure buildup. Can be sprinkler or opening. Secondly, there are requirements for this door. Has to be self-closing in case of fire. Obviously, has to be fire resistant, and it has to be smoke control. Fire resistance, they give an option if you use sprinklers here, it's not necessary. You can argue saying that why do we need here a smoke control door if there's a measure to eliminate pressure buildup? Because if there's no pressure buildup, why do you need smoke door? The reason is in case of an opening, there's still overpressure. You will never have 0 pressure difference. And any overpressure, as slow as possible, will give you smoke propagation. So, smoke control doors. If you have sprinkler systems, okay, it's very good if you have fully developed fire, of beginning of a good fire. But suppose you have a smoldering fire, creating a lot of smoke, no heat, but again, sufficient pressure buildup to push the smoke through the door. And that's the reason why this is also important. Do you need requirements from the room door? Of course not, because you are evacuating through it. So if you want to evacuate from here to here, in case of this configuration, these are the requirements. Yes?
I've got 2 questions actually.
Yeah?
The fire systems that you have below 1 on.
Sorry?
The fire system door, the common area door.
This one?
Yeah.
Yeah.
Marks in 1.
Yeah?
Not necessary when automatic suppression.
Yeah.
System is applied. Have you analyzed that in the case of risk analysis when there's actually a possibility that the suppression system doesn't work?
No, no,
So you haven't compared it to a risk analysis?
no, no.
And the second one is the door, you said the room door.
Yes?
The analysis, the requirements over there are based on the common area.
Yeah, yeah, yeah.
Would you have an argument having a fire resistant door in case of fire in the room? You know, elderly people have a tendency to smoke in the bed, even though they don't know how.
No, well, I will. That's also one of the conclusions from the presentation for future work, because this is very correct what you're saying. This is common area fires there. If you have a fire in a room, it's different, because in this case we assumed everybody's out.
Yes.
If you have a fire in a room, you don't assume that everybody's out. So it means that it's. Yeah, well, if somebody is in the room and there's a fire, you want to help them, you want to evacuate them if possible. So meaning that all these things, it's self-closing in case of fire, but if the door is closed, then you have all these things. In case of a fire in a room, that hasn't been investigated because there are other things that matter there. But that is something we would like to do later on.
There can be fire in the common area. You exclude
Yeah.
the chance because of
No combustible material.
But there can be there is probably a television or electrical.
Yeah.
So there can be a fire, and then you have 8 to 10 people that have to be.
Yeah. Well, that's the other configuration. So this is when your room opens to evacuation route, but you can have also your room directly connected to the common area. And then your common area is your evacuation route. So you have a fire in your evacuation route. And that will be discussed in the next slide. Any other questions on evacuation from the room? If we do defend in place, can do that, meaning that they stay in the room here. What kind of requirements do you need? Do you need measures to eliminate pressure buildup? No. We've seen during the second test, as mentioned, that if you have a fire here and this is closed and this is closed, you don't have smoke there. So if you stay in your room and this is closed and this is closed, you're safe.
But the all 3 rooms you have? Yeah.
D?
Yes.
Yeah, but that's the other slide. Now we're focusing on this one. Yeah, but you're right. You're right. But if so, repeating, defend in place. Again, if this is closed and this is closed, you're assumed to be safe. I'm saying assumed because that results from the fire test. If we go now for the tricky part, is these configuration. Again, staff and fire detection system, no problem. Measures to eliminate pressure buildup. Now, of course, we don't need this door anymore, but this door, and we have the additional exit. We go to evacuation strategy, evacuation from room. Conclusion from the safety level was, you cannot evacuate to a fire room. So, if you cannot evacuate through here, the only way out is here. I think that's obvious. There are some requirements here. So self-closing if is of course very important. There are some requirements here also. Suppose you have an additional exit here, but your person who is here is not self-reliant. That means that he needs assistance to go out. Then you will have, of course, elimination of pressure buildup there, and you must prevent that smoke comes through. But at that point, we come to the defendant place. Oh, defendant place, where you're sitting here. If you are directly connected to the fire compartment, what was the thing we have to do is to eliminate that your pressure buildup will put smoke in the room. So we eliminate that. These requirements for the door are self-closing, fire-resistant, and smoke-control doors. So if you eliminate pressure buildup and you keep the fire there and smoke there, then you can assume that if you do defendant place, that you're safe. Yes?
How do you keep the people in the room? Yeah.
That's a very good question. We don't know. There was a discussion during the previous presentation also. If you have, for instance, dementing persons or person that you don't know how they will react. You don't know it. But defendant place in Belgium is very, very new. Because you always want to evacuate as soon as possible. Sometimes it's not possible. And in this case, if the person is not mobile, he needs assistance. But if we see, like in this case, we have to go to smoke in case of the elderly, it's not possible. So what we should advise is, of course, that's the most, I think everybody agrees, if you have an additional opening, there's no problem. Of course, there are a lot of architects and builders and so on. They don't want that. You remember the configuration in the beginning, it's nice and cozy, and every time it comes to a common room, they don't want that. But if they don't want that, they have to take into account that the only possibility is defendant place, taking these measures into account. How they will react, I think we can discuss a lot about that. And even so, as after this study, also one of my conclusions, they will look at these results can be used for other kinds of institutes. But then you have a various type of occupants. You can have any kind of occupants, and some can be, or some will be stay in place, but others will freak or, to be honest, if somebody says you have to stay in a room during a fire where you hear the sirens, I don't know what I should do. So it's a fundamental question. But the purpose of this one is to say, okay, this is the only possibility. Especially if your room is directly connected to the fire compartment.
Is this based on a common situation? Because I thought when we built some kind of building with the rooms, we extract the evacuation route just in front of the lower rooms.
Here.
So there will be a longer evacuation route just in front of the rooms.
This is based on.
It's really
yeah. Well, I can.
The rooms are connected with the
yes.
common area.
Yeah. The first slide, one of the first slides that I shown, it's this is how they build it. And everything has to be open, so the common area becomes very large, and they want all these rooms connected to that.
It is allowed in the Belgian legislation to build it this way, or is this?
This is for
the space, which should be a traffic area.
This is, you have to keep in mind that in Belgium, or this is Flanders. You know, Belgium is very complex, and
now we don't do the discussion now.
No.
Because
but
we don't want Belgium back.
Why? No. It's only applicable for new buildings. So that means you have your prescriptive legislation, you have to comply with that. If, like I said, if you deviate from the legislation, you have to prove that you're... So this table and the other one are used by the Technical Commission to see, okay, we have a situation like that, we will impose that, that, and that. So if you say we have a situation like that, then you can build it on the condition that you apply that or that. That's, I think it's different in the Netherlands where you can...
Equality principles.
But this is more or less the same, but it's also some things are applicable for old buildings, no? In Belgium it's not, it's only for new buildings. So retrofitting in this case can be very tricky or difficult. They will not, this one is only possible during building. Yes?
Can the common room still be used as a living space?
Yes.
So, well, I'm troubled about that because then defending place is not possible because there will be people in the common space.
Yeah, but
so you can have all kinds of regulations and measures for the blue rooms in this picture.
yeah,
The people are actually sitting in the sofa waiting for the dinner or looking.
that's in a common area.
in the common area.
So
Yeah.
your room
So
yeah.
So they won't be in the. They're not demented, but they will be living in the living area.
Yes, but at the end, yeah, I understand.
For,
Yeah,
safe evacuation if you're
no,
in the living area, and only by taking
No.
some severe measures,
Yeah.
you can be safe
Yeah.
while staying in your room.
no. You have that's a very good question or remark. Something I forgot to tell you that this is typically for night activities. So day activities are not that a problem, but it's more for people who at night. If something happens in this area during night, it can have problems for these people, and you have to.
And during daytime, what's your?
During daytime, it's like you're saying. During daytime, there's a lot of more staff available, so they're already in the compartment. They will not, if they have to evacuate, they will not go to their room. They go directly outside.
But they probably will have to escape through a smoke-filled room.
Yeah. Well, and also, like I said, staff is very important. During night, 1, maybe maximum 2. So and when they do, when they are treating deviations from legislation, they are looking at what kind of activities. Is it day or night? If it's night, it's more severe. And they also, I think they also have some rules about maximum power of electrical equipment in your common area. So there are still some requirements. Any questions on these? No? Then we're already at conclusion, so again, as a conclusion, the desired fire safety levels for the elderly and Flanders, again, I don't know if it's in other countries so, but here we have determined a safety level. You cannot expose them to smoke, or you must avoid smoke exposure, and you cannot evacuate to a fire compartment. That's basically saying smoke and elderly, keep them separated. In order to prevent smoke propagation, we have seen that you can have fire safety measures, and what kind of fire safety measures depend on configuration of the room, if it goes out to the evacuation room, if it comes out to the fire compartment, and the evacuation strategy. You evacuate from your room, or you stay in your room, or the defend in place strategy. And there I put future work, so they will investigate more in detail how these conclusions can be used for other facilities, and also the influence of the location of the fire. For instance, in the room. Because now they just looked at a very specific location, but if you look at another, and then you have a complete picture. Any other questions? No? Yeah.
Maybe it's wrong to say, but this means that there will be lots of money spent on making it safer. And your purpose is to save everyone.
No, no, it's not much more expensive. For instance, a smoke control door, the difference between a smoke control door and a fire resistant door, it's only the rubber.
No, but in combination with the smoke extraction, in combination with
Smoke extraction is not mentioned here.
No, in the other situations.
Smoke extraction is not as a measure. It was an opening or sprinkler to eliminate pressure buildup, but smoke extraction is not mentioned as it was used during the tests, but not because that's expensive, and that's why we did simulation on. You have a ventilation system, we double the volume flow, and we look if that's sufficient, but it wasn't sufficient. So you need an upgraded ventilation system, but that costs money, and in this case. The only thing is you have smoke control doors, so that's not much. It's more or less the same as smoke fire-resistant doors, and you use residential sprinklers. So these can be they require only low bar. I think 0.5 bar or no pressure. So it's not that difficult, of not that costly to implement them, and that's always the purpose of changing legislation. It must be as cheap as possible.
Have you already implemented the results of this test or this project into practice? I mean, to any new legislation or guidelines or something like this?
These results, these tables that I've shown you, these are actually used for derogations, and they will change the legislations, but as you know, that takes some time. But at this moment, and that was the purpose of the study, they wanted to have something they can use to see, okay, if you do it like that, this will be the result. And that was something they didn't have. And now they use these tables for that. Yeah.
Have you got different levels for the elderly? Because what's the elderly? Are that just people in wheelchairs or people, well, you can have different levels of being disabled? Yeah,
but that's depending on self-reliant or non-self-reliant. That's already a distinction. But we considered elderly, it's hard to say, but people of higher age. And we were looking at smoke. So if you are non-self-reliant or self-reliant, if you inhale that smoke, yeah. So, and it also depends on how the condition of your person is. Yeah, that's correct.
Did you compare the results of your tests with the literature or other tests run in different countries?
We, like I said in the first phase, we looked at legislation in other countries, and in every country I've looked at, it was not allowed. And not allowed is meaning this. It's not allowed. I'm not saying that it's applied, but according to legislation, this is not allowed. You are not allowed to put a fire load in your evacuation route. Sorry? A fire load in your evacuation route. If you want to do it, you have to compartment. So.
But you could, if in Denmark you were able to create a door from the room directly out.
Yeah, yeah.
So you won't need to use the common area.
No, no, no.
Or it's not in all the situations that it needs to be a door. A window would be perfectly good.
Yeah. Yeah.
Is that on the ground floor or is it on the first floor?
It depends. It depends. If you have, you can argue a balcony, for instance. If you have a balcony and you're outside your balcony and you're safe there.
That would not be sufficient.
No.
Not for the elderly.
Well, it depends. Suppose this door is always closed. Suppose this door is closed. It's fire-resistant door. It's not smoke-free. You don't have measures to eliminate pressure buildup. So the smoke comes in here. And you're sitting here on a balcony along. I'm not saying that's the. Normally, you use that one to evacuate. And I didn't find in any legislation that this is allowed. Like I said, it doesn't mean that this is applied. Because Belgium, prescriptive. France, prescriptive. Sweden, performance-based. UK, performance-based, prescriptive. The Netherlands, I don't know anymore. So what I mean, you can deviate from legislation as long as you prove that it's the same safety level. But what is the safety level?
I have one question concerning the defendant place.
Yeah.
Did you find in the legislation of other countries that this solution was regulated?
Oh, it was a long time ago, the study. I don't think so.
Are you going to regulate in this, let's say, future regulation?
That's a tricky one. Yeah, but because I don't think it's in any legislation mentioned that you use a strategy to defend in place.
Yeah. Because when you told us about the assumptions
Yeah.
you took during this test, of course there are many simplifications, as usually, because normally in the development of the fire and spread of the smoke, it depends on many other reasons.
Yes.
For example, if somebody opened the windows.
Yeah.
In the room, for example, in the room. If the direction and speed of the wind and
Yeah,
things
that's
like
it.
that,
Yeah, that's not
that's
all.
why the defendant place it will be very risky, especially in such type of buildings where the elderly people live here.
Yeah, but it's
Maybe there will be no choice.
yeah, that's correct. Well, like I said also, it's not only the fire door that's important. If you have ventilation system and the shafts connect this one with this one, yeah, why bother putting a smoke-free door then, if it comes to the ventilation system? So it goes much further than this one, but you have to keep in mind this was the start. And as you know, during a study, you see things and it complicates more and more, and then I think every study ends with future work.
Life is complicated.
Yeah. Yeah.
You don't have, regarding with the ventilation system, you don't have a building code saying that you need to fireproof your.
No. Fire resistance, yes.
But you don't have.
No.
Either you have a damper that goes.
Yeah, but the damper, for instance, the damper would be located here, but will be a fire-resistant damper, not smoke-resistant.
Oh, you don't. Okay.
Like I said, and before that study, smoke control doors were never mentioned. They put it in some and some of the federal legislation, but it was never considered, because it always was considered if you have fire compartment, you put fire-resistant doors, and that should be sufficient. And that I found in UK or Sweden or the Netherlands, there the concept of smoke control and compartments is already integrated. And now they see that, oh, it's a problem. Smoke propagation has I'm not saying neglected, but in case of, like I said, adult, self-reliant, healthy persons, if you go to a little smoke, it's okay, but in case of the elderly, it's completely different. Yeah. Nobody? So I want to thank you very much for the last presentation of the day. And if you have any other questions, you can always ask me, but thank you for your attention.